Okay, so we're dealing with simultaneous equations. Okay, here we've got three variables. We have to find the value of x, y, and z. Okay, so we're going to use Cramers rule. Okay, so we're going to do it in steps. Okay, so we say step one, get the overall determinant. So the way we're going to do that, we need to form a matrix. Okay, so form our matrix here, and we put the coefficients of these equations here. Okay, so the coefficient of this x here is 1. The coefficient of this 2y here is 2. The coefficient of this 3z here is 3. We go to the second equation. The coefficient of x is 3. The coefficient of y is 2. The coefficient of z is 1. We come to our bottom equation here. The coefficient of x is 1. Coefficient of y is -5. The coefficient of z is 1. So, once you make your matrix, okay, you're going to get the first two rows in your matrix. Okay, not first two rows, first two columns. Okay, so this column 1 3 1, you put it outside. 1 3 1. This column 2 2 -5, you put it outside. 2 2 -5. Any questions? So we're going to use the arrow method. Okay, basically we're going to be using the leading diagonal LD. And the diagonal is going down like this, like the demand curve. That's the leading diagonal. And the diagonal is going like this, the supply curve. That's the trailing diagonal. Okay. So the way I like to do it, I like to start first with the leading diagonals, get their values, then go with the trailing diagonals. Okay, so if we start with the leading diagonal, what color can I use here? So you come 1 times 2 times 1. Okay, this is our first diagonal here. This one in this arrow in purple. Okay, we say 1 times 2 times 1. We get 2. Any questions? Plus We use our second leading diagonal. 2 times 1 times 1. 2 times 1 times 1, we get 2. Plus 3 times 3 times negative 5. 3 times 3, that is 9. 9 times negative 5, negative 45. Any questions, colleagues? So 2 plus 2, that is, that a question? Ask. Oh no. Yes, it's the same one. The same one. Yes, it was confirmed that you can also use this one. So, since you can use this one, I don't think we should be too adventurous to use that other long method, since it's been confirmed that you can use this method. But if you are given, um, mhm, mhm. Let's do our tabulations. We see what we get. Yeah. Yes. So 2 plus 2, that is 4. 4. Oh, well, this positive and negative here. So this becomes minus. So 4 minus 45, that is negative 41. Confirm, colleagues. If 2 plus 2 plus negative 45 gives you negative 41. Okay, so now we work with our trailing diagonals. One times two times three, you're going to get 3. So remember, colleagues, the diagonals, the leading one starts from the top number, the bottom one starts from the bottom number. Okay, this number in the middle, no diagonal is going to pass through it, and this number in the middle. So when you're doing this technique, just make sure this one in the middle and this one in this other middle here, they're not touched. Otherwise, if it's touched, then you're doing something wrong. So 1 times 2, that is 2. 2 times 3, that is 6. The next one, negative 5 times 1 times 1. That gives us negative 5. Let me just put here the plus sign. So here, plus. One times 3, that is 3. 3 times 2, that is 6. Six plus negative 5, positive and negative make negative. 6 minus 5, that is 1. 1 plus 6, that is 7. So remember, once you've done this part, before I go further, any questions? Okay, so remember, it's a leading diagonal minus trailing diagonal. Okay, so for our leading diagonal, these ones at the bottom here, negative 41 minus trailing diagonal. The trailing diagonal, these ones on top, we got 7. Negative 41 minus 7, you get negative 48. This is our determinant. I forgot to mention that. This is the determinant. Any questions? So this is our first determinant, negative 48. That is step 1. Step 2, get the determinant for x. Okay, get the determinant for x. Now here something special happens. When you're getting the determinant for x, okay, this 17, 11, and negative 5, okay, this column here is going to replace the x column. I'll repeat again. When you're getting the determinant for x, those last numbers in those equations, okay, they're going to form a column. Okay, these 17, 11, and 5, they're going to form a column. And they're going to replace the original x column. When you're getting the determinant for y, this same column again, 17, 11, negative 5, is going to replace the y column. When you get to the determinant for z, this same column again is going to replace the z column. Okay, if we look at our matrix, our x column is the first column, our y column is the second one, our z column is the third column. Okay, so whenever we're getting the determinants for these, their respective columns are going to be replaced. Okay, so whenever you're getting a determinant, first thing you do, you make a matrix. Okay. So our x column, since we're getting the determinant for x, will be replaced by 17, 11, -5. Okay. Replace that column with those numbers. Then the y column stays the same, 2, 2, -5. The z column remains the same, 3, 1, 1. Then after you make your matrix, remember the first two columns come outside also. So this 17, 11, -5. And this 2, 2, -5. Any questions, colleagues? Remember, where you have a question, stop me. Okay, say, sir, just hold on. I have a question there, okay? Mm, mm. Oh, yes, yes. When I began the class, I said that we confirmed that this method can be used in the exam. Yes. So since it can be used in the exam, we don't. We it's better to be more efficient. Okay. Because remember, efficiency is all about utilizing resources. Okay. So the resource we're utilizing is time. So with this method, it's faster and I think it's even better because that other method, ish. Mm, wouldn't have finished tonight. I wouldn't have finished tonight. Yes, Mr. Twam. Yes. 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 Someone confirmed in the class. I've forgotten who, but they confirmed. Okay. Madam Yvonne, Mr. Sydney, are those questions? Okay. Okay, okay, okay. They're both Cramers rules. Uh, yes. Sir, no, 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 no. Okay, yes. You know what? Yay! Colleagues, I was actually thinking my prayer was answered so that I don't go through that first one. Because that first one, but anyway, I'll take you through. Okay, I'll take you through. It was just that when I heard that confirmation, I even celebrated. I was like, thank God, not that method there. Okay, so I'll make you go through, but after this one, after I explain this one, see which one you like. Okay, but I'll walk you through. Okay, I'll walk you through. Because even I've got videos for both methods, so but I'll still walk you through. Okay. Yeah. Any questions on this part so far? Okay. So here, let's all participate so that because when we start seeing big numbers like 17s and 11s, eesh, you have to be very careful. So we start with our leading diagonals. Okay. So we start 17 times 2. 17 times 2, that should be 34. 34 times 1, 34 plus 2 times 1, 2 times negative 5, negative 10. Okay, thank you, thank you. Plus 3 times 11, 33. 33 times 5, negative 165. Okay, so 34 plus negative 10, that should be 24. 24 plus negative 165, what do we get? 161. Okay, is it negative? Yes. Colleagues, let's confirm because when we reach the last part, wouldn't be nice if we got a wrong figure. So are we all getting negative 141? Okay. Then we start with the trailing diagonal. So let's come to the bottom number. You say negative 5 times 2, negative 10. Negative 10 times 3, negative 30. plus negative 5 times 1, negative 5. Negative 5 times 17, what do we get? Okay, negative 5. 1 times 11. 11 times 2, 22. Okay. Okay. So we add negative 30 plus negative 85. Confirm negative 115. Then negative 115 plus 22. And we get negative 93. Okay. Colleagues, are we all getting negative 93? Okay. So the determinant for x, leading diagonal. So you look at the bottom number, you put it first. Negative 141 minus trailing diagonal number, negative 93. Okay, so this is the same as negative 141 plus 93. What do we get? Because negative and negative make positive. Okay, negative 48 dx. Any questions? Step 3. Get determinant for y. So what's the first thing we do? What is the first thing that we need to do? Are you there, Mr. Sydney, Mr. Twambo, Mr. Vince? Mm, yes. In the y column, yes. Okay. So in our x column, so just remember what. This moving column, it starts when you start your determinant for x, okay? When you're getting your overall determinant, you're not column. Mr. Tuambo, we're hearing. Okay, so 131 x column, y column 311. Okay. Then what do we do next? Yes. Thank you. Thank you. Yes. Then we start the process again. Okay, we start with our diagonals. So in the exam, I would advise if you're doing this question, come with three pens, one red, one black, and one blue. Okay. So don't confuse yourself with these arrows, because and make space in your exam paper. Your working sheet, make space. Okay, because these arrows will confuse. Huh? Using it. Okay, black and blue. Yeah, yeah, yeah. I can't think of it. Yeah, red. I don't. Red. They'll start thinking other things. Yeah. Okay. Okay. Yes. Yes. I believe even these multiplications which I'm doing here, depending on if you saw how the professor was showing it, maybe did you see? Did you see how he was showing the workings? Okay. Colleagues, was he showing these multiplications for these diagonals here? Okay, so you have to show these multiplications there. Okay. I think you might lose marks for the way here, the shortcut which will just multiply like that. Because maths is all about the steps. So yeah, madam, thank you for bringing that up. Okay. Okay. So 1 times 11, 11. 11 times 1, that is 1. Huh? 11 times 1, that is 11. Seventeen times 1, that is 17. 17 times 1 again, that is 17. Plus 3 times 3, that is 9. 9 times negative 5, negative 45. So 11 plus 17 plus negative 45, what do we get? Negative 17. All right. Then we go to the other diagonals, the trailing one. 1 times 11, 11. 11 times 3, 33. Negative 5 times 1, negative 5. Negative 5 times 1 again, negative 5. Plus 1 times 3, 3. 3 times 17, huh? 51. Okay, so on top, 33 plus negative 5 plus 51, huh? 79. All right. Yes? Which one? This 1 times 11 times 3 is positive. This one here it's negative 5. This third one here is positive. Mm, the only negative is this one that came from the middle one. So yeah, I believe. So colleagues, let's confirm. Is it 79 the answer that's here? Because one thing about Cramer's rule is when you reach the last part and you realize you've made a mistake, looking for that mistake is it's hell. Looking for that mistake. Mm. So leading diagonal negative 17 minus trailing diagonal 79. So negative 17 minus 79, huh? Negative 96. Okay, so that is dy. Final step, step 4, get determinant. So just remember this Cramer's rule, you're just getting determinants, okay? That's all you are getting. And here I need someone to now lead me to see if I've got the concept. And here someone guide me. What do we do next? Uh-huh. That's what I'm encouraging. Uh-huh. Column. Okay. Yes. Uh-huh. Continue, sir. Continue, sir. I was just putting these numbers here. Has he been kicked out? Was that Mr. Sydney? Or Mr. Vincent? Oh, what has happened? He's gone mute. Maybe network. Okay. Um, Maybe anyone to pick it up from there. Mr. Vincent. the first two, the first two columns are the ones moved outside. Yes. No, it's okay, sir. It's okay. It's part of learning. Yeah. Why is the first? Mm, I don't know the reason why, sir. I don't know the reason why. But just remember, every time you make that matrix, the first two columns are the ones you put outside. So we get our diagonals. 1 times 2 times -5, -10, plus 2 times 11 times 1, 22. 17 times 3, 61. It should be 51. 51 times -5, -255. Okay. Okay. Oh, Mr. Sydney, you're back. You can you can pick it up from here. Okay, -243. Colleagues, let's confirm. Are we all getting -243? Okay. 2 30. Okay. Mm. Mm-hmm. I've put negative 255. Are you saying the final answer should be negative 255? Ha. Cramers rule. Ha. Cramers rule. This one you only do it during the day. Not sleeping time. You see these patterns you're saying before you sleep, you see them. Okay, Mr. Sydney, you can continue. Uh-huh. Uh-huh. Mm-hmm. All right. Mm-hmm. 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 Negative 30. All right. Mm-hmm. 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 Negative 51. Colleagues confirm. Negative 51. Okay. Okay. Yes, miss. Diagonal. Mm-hmm. 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 Negative 192. Okay. Colleagues confirm. Okay. So after you've got all your determinants for x, y, and z, and the overall determinant, you can now find your values. Okay. So to get x, is the determinant of x divided by the overall determinant. Okay, that first determinant we got. Okay, so the first one we got our d was negative 48, and dx is negative 48. So negative 48 divided by negative 48. we get positive 1. Any questions? Mm-hmm. Yes. The determinant found for x was also negative 48. Okay, remember here. Then the overall is also negative. So just remember, the overall determinant is always going to be the denominator. Okay. So for y, it's dy divided by d. Dy, if I'm not mistaken, was negative 96 divided by d is negative 48. 90, negative 96 divided by negative 48. 2. Okay. Negative 96 divided by negative 48. It's the determinant for y. Okay. Z, it's dz divided by d. Dz negative 192 divided by negative 48. 4. 4. Okay. So for your answer, you're going to say x equals 1, y equals 2, and z equals 4.